It can be bigger method.
क्योंकि एक लाइन में 64 मेमोरी ब्लॉक्स आ सकते हैं.
Why? The reason is that now if we have now we have 64 kilobyte memory. If we have 128 kilobyte memory, then what will be the tag field? 7. It is 256. 8. Okay. Now it means that how many main memory blocks can be mapped to this site? No.
2 raised to power
A
6
total of 2 raised to power 6 blocks are mapped to this
can
site.
be mapped. Yes, sir.
So it means 64 blocks, and the chances of conflict misses are more when we increase the main memory size.
Yes, sir.
If we increase the main memory size, now it is a direct map cache. Any type of cache. In any type of cache, now we say that if we increasing the main memory size, so the number of blocks that can be mapped to a particular sets are now more. When there more blocks are mapped, so it means that this tag field identifies how many blocks
Of main memory
are mapped to a particular
cache line
set, not cache line.
set.
It's in the direct cache because it's a one cache line. Okay, what is the index field? Identify. How many what? Sets within what? How many sets are there within the cache? ठीक.
इसके रिकॉर्डिंग है तो उसकी रिकॉर्डिंग
चलो इसे. Okay. Okay. So now even relevant to this problem, we can say how many main memory blocks are there within the memory. How many memory blocks? So how many memory? Total number of memory blocks. Total memory blocks is equal to memory size divided by block size. What is the memory size? 64 kilobyte. What is the block size? 16 bytes. So 2 to the power 6, 2 to the power 10, and byte, and it's 2 to the power 4 byte. So actually 2 to the power 16 and 4 to the power 12. So how many? It means that how many blocks are there in memory? There are 4096 blocks. So can we write it like this? So actually it is memory block 0, memory block 1, and the last one. What is the last block?
4095.
The last block is actually main memory block 4095.
95.
So the last block is 4095. If you look at this 4095, but if you say, so actually the total, what is the total memory capacity? So we can, if you want to calculate the total memory capacity, can we calculate it? Actually, if you look at the main memory block address, so actually this is 16 bits, am I right?
Yes, sir.
The least significant 4 are dedicated for
Byte.
byte, and the most significant 12 bits are the main memory block address. Okay, the main memory block address is further partitioned into 2 fields. What are these fields?
Index and tag.
Tag and index. So the index identifies what? Set. And the tag? Block within a set. So the total memory capacity is equal to block size multiplied by number of blocks. Now pertaining to this problem, if we say that microprocessor has generated an address 32F5, if microprocessor has generated an address 32F5, what does it implies? G. If you convert it into binary, okay. If you look at the least significant bits, which byte is this?
5 bytes.
Byte 5. Index start from 0. So it is actually byte number 5. Okay. So now 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Which main memory block number is this? 512 plus 256 plus 32 plus 8 plus 4 plus 2 plus 1. If we calculate this, G 512, 256, okay, 32 plus 8, 40, 44, 46, 47. So it is actually main memory block 815. So actually it is lying somewhere in between. So here it is. If you look at this main memory, if you look at this main memory, so there is some address. So there is some block. Main memory block what?
815.
815. If you look at 815, so actually we have byte 0, byte 1,
byte 15.
byte 5, and the address of that is what? 3285. And this 3285 belongs to main memory block 815. If it's 815, now we are done. What is the index field? How many bits are required for the index? 6. 1, 2, 3, 4, 5, 6. So this is the index field. And if we calculate this, 32 plus 8, 40,
47.
44. So the index field is 47. So what does it imply? It is mapped to
Cache line.
set number
47.
47. How many sets are there?
2 to the power 6.
64 sets. So actually it is mapped to, so it may actually this main memory block 815, main memory block 815 is mapped to set number 47. Okay, so how we can determine the set? Set can also be determined. Set can be determined. Set number is equal to main memory block number in percent. In percent is the remainder operator. Is the remainder of number of cache lines. Number of sets. So what is the main memory block number? 815?
Yes, sir.
815? In percent, how many lines are there?
64.
64. So if you perform the divide operation, 815, 64, 64 ones are 64. 175. 64 multiplied by 3.
2 current, sir.
62. 128. 5.
7. 47. Yes, sir.
Agreed or not?
Yes, sir.
देखिए आप लोग जो है ना हम पुराने लोग हैं, हम यहाँ पे कैलकुलेशंस करते हैं विदाउट कैलकुलेटर. अब ये जो ना फार्मी लोग हैं, फार्मी. Okay, so now if you look at here, so this main memory block 815 is mapped to set number 47. So this is the formula. Set number is equal to main memory block number. What is the main memory block number? 815. What is the number of sets? 64. So now we have calculated the set number. Okay, what is the remaining bits? These bits. Tag field. So the tag field actually fields are 1, 2, 4, 8, 4, 8, 12. So the tag is now 12. So the tag of this memory block 815 is 12. Which block should be mapped here? अच्छा देखिए आप यहाँ जरा गौर से देखिए. Which block should be mapped here? 47
plus 64
47 plus 64 47 plus 128. So its tag will be 0. Its tag will be what? 1 and block 815. Its tag is now what? 12. So actually it is the 13th block because the tag starts from 0. It is the 13th block, 13th number within this series, and you can verify that.
47 plus 13 into 64 से 815 आना.
So can we do it like this? So can we say like this? It is equal to 47 plus 12 multiplied by 64. याद है कि वही चीज है ना? 47 plus
12 into 64.
वही चीज है ना? यहाँ पे मैंने I have proved it. 47 plus 1 multiplied by 64, 47 plus 2 multiplied by 64, and 64, 47 plus 12 multiplied by 64. So now there are different ways. आपने जो है ना उसको देखना है कि आपको जब concepts आपने बनाने हो तो you have to dig into more details. You need a very good mathematics and how things